Alright, so tonight I'm going to do a little video on even and odd or neither. And again, I put in yellow here, that an even function, when you substitute negative x, you end up with the original function, meaning that reflects across the y-axis. So it mirrors. So if I do this and I put in negative x, and again, what I'm looking for on this is the proof. And I mean, you have to justify what you're doing. You can't just say, it's even or odd. You actually have to show like negative x here, right where I just wrote it, becoming positive. Alright, right there. And what happens here is I'm looking for this step. I'm looking for negative x over, now negative x squared is x squared plus 1. And then we sit here and say, oh, okay. If I scroll down, I have to move down on my screen here a little bit. But if I do this, then what I can do, and when I factor a negative, I got to be clear about this. It just comes out of the top, right? And then all of a sudden you're left with the original function. And once you've done this, you can say thus odd. But I'm looking for that proof all the way through. So on this 74, and again, let's take a look at this one. Alright, if it's x squared plus 1, x over x squared plus 1, boom, you can see this function is odd. It reflects across the first to third quadrant. It goes through the origin. This is an odd function. If we do the even function, and I know it's even because I can see the powers, but at the same time, I have to make the proof. I'm looking for us to do this step. Put negative x in. Show the quantities getting squared. Show the quantity to the fourth. And we know even powers result in positives. So we're able to do this step. And that means we're able to write this. And once we do this, we have an even situation, thus even. We know this reflects across the y, thus even. So again, if I go to Desmos and I prep this up, here's our function, I turn it on, boom, you can tell it's even. This portion mirrors over to this portion. Alright, it doesn't have to go through the origin, it does this time. Just a couple more here we can try to do. Alright, so again, it always starts with the same thing on the proof. Let's put in negative x. I get negative x on the top, I get negative x plus 1 on the bottom. Doesn't change the sign of the plus 1 here, okay? So I'm looking at this and all of a sudden I know, well, I can factor a negative, and it kind of looks like the original function, but it's not. And again, this is a case of it's not the same, it's not negative, so this is neither. And if I again show, if I go over here and show this, turn off the last one, which was an even, and I turn on this one, boom, it goes through the origin. But remember, if it was going to mirror here, this portion of the curve would have to be here, right? And it's not. So again, this is, now it is mirrored across a line here, right? You can see how there's a y for x line here. But again, this is not an even or an odd. The last one's a little tricky. So I do negative x, and I get negative x times the absolute value of negative x. And here you just got to realize that we don't care what the absolute value of this is, right? No matter what happens, it's going to be a positive. So I can just go back to this. I can pull out the negative sign, and it's right there. So I know that this stuff right here, is originally f of x, thus odd. And again, if I jump here and show this, and I have it as x, absolute value of x here on Desmos, boom, again, you can see that this mirrors across a line, and it mirrors from the first to the third, or mirrors across the origin here. And again, this is an odd function. This is the proofs you need to be able to do. All right, you got to know that it always starts with substituting negative x right here, or here, or here, or here. Okay, this is in section 1.1 of the Stewart Calculus Textbook for Practice.